Moderation is sweeping the nation. Okay, moderator is a variable that when linked up with another variable, the combination of those two variables are affecting the DV like a third variable. That's what moderation is. So we're going to check this. So let's just run a regular regression. The DV is weight gain in this one. And these are your IVs. So what we do is, like always, check all these guys and do the plots. And again, I'm just going to check the moderation part. In real life, you guys would actually be checking all these assumptions on your own. And let's take a look at what we got here. Don't care about descriptives, correlations. You got some low ones here and some high ones here, but let's go down to the model. Pretty good R squared. And the ANOVA says it's significant. Good. So let's look at the coefficients. So according to the coefficients as they are, it looks like only work hours per month is a good predictor of weight gain, right? So the more hours you work per month, I guess the more weight you gain. Actually, the more you lose there, right? Because it's a negative value, okay? So that's the only one that's significant, is how many hours a month that you work. But now, this is the boxes you're going to look at to suspect that something is either a moderator or a mediator. You're going to look at the correlations box right here, okay? So the first one is sugar calories, and you'll notice it starts out real low, but then when it interacts with other ones, right, the partial allows overlap of other variables, it goes up. It goes up more than twice. There's something suspicious there. This one stays pretty much the same. It goes up a little bit. This one goes up a little bit. So they all go up a little bit, but this first one goes up a lot. So that makes me suspect that something is going on. So this is how we're going to check for moderators. We have to create several new variables. And the first one, we're going to center each one of these: sugar, calories, fat, calories, work hours, monthly. We're going to center them all. So we're going to, first of all, we're going to find out what the means are of those guys. All right, sugar, fat. These are our predictor variables, and we only want the means. And we're going to go find those means. Hold on. Bam. Found them. Okay, I'm just going to use whole numbers. These numbers are so big, these little decimals really aren't going to make a big deal. So 1568 for sugar. So here we go. We're going to go to transform, compute a new variable. We're going to call it sugar centered. Now we're going to stick the sugar over there, and we're going to subtract the mean. And I already forgot what it was. 1588. Let's take a quick look. 1568 minus 1568. Now we have a centered variable. Let's double check on our data sheet. Make sure we have a centered, sugar centered, and there it is. Okay. So I'm going to repeat that process with all three of them, but I'm going to pause the video. Done. Magic of videos. So remember, these centered variables, these numbers represent pure variance. This is the number away from the mean this first guy is, number away from the mean the second guy is, etc., for each one of these. So once we've centered the variables, we're going to go ahead and create new variables that are the products of these things. So we're going to go and compute a new variable. We're going to reset that. So we're going to take the sugar centered, and we're going to multiply it by the fat centered. That will check to see if there's any interaction between sugar and fat. Okay. And we're going to call this sugar times fat. Two of my favorite foods, by the way. Click OK. The next one, we're going to compute a variable. We're going to call this one, let's call it work hours. Times fat. And we can take a shortcut up here, just delete that one. And click in our work hours centered. And okay with that one. Next one, transform, compute. And let's see, let's do work hours times sugar. Centered. Ah, sugar. Come on, honey, honey. Got it. And the last one has to be all three of them. So, compute. So I'm going to do times fat. And then we go over here, and then we do multiply, and then we do, where's my fat? There's my fat. Okay, so I got work, sugar, fat, all centered, all multiplication. So we literally made 4 new variables, all interaction terms. We're going to double check all of those things. Okay, so since we made them, we're going to go to Analyze Regression, Linear. Let's reset this bad boy. So the dV is still weight gain, but now we're going to stick in the centered variables first. We only do that because it should be exactly like the original regression, right? The centered variables are pure variance, and we should get the exact same results as we did with the first one. And we're going to treat this like a hierarchical, right? We're going to check the significant R squared changes to see who's who. And so next. And now we're going to put in the first interaction term, sugar and fat. Next. And then work hours and fat. Next. And then work hours and sugar. Next. And then all three. That's the last one. And like always, we want everybody up here. We want our plots. The Z pred on the bottom and the Z resid on the top. Click, and we want the Mahalanobis. Again, I just do this by reflex. And we click OK. And I believe we're ready to take a look at this thing. Okay, let me pull this up so you can see it. All right, don't care. And just make sure you enter them in properly. So here's the model summary. So let's start looking here. Okay, so the first model is with the dV of weight gain. All of these are the same dV, weight gain. So this one is the original 3, right? But they're the centered, and it was significant. We knew that already. And we're going to scroll down, and the ANOVA boxes, we really don't need to look at that. So we know that salary is a significant predictor. I'm sorry, salary. That was the last problem. Hold on. Sorry, you guys couldn't find the original regression, but here it is. Here's the original regression before we centered anything. And as I recall, the only one that was a significant predictor of weight gain was your work hours monthly. You're right, and that was the significant guy. These other two are not. The correlation box, that's your hint maker, right? If you have a zero order correlation that changes radically into the partial or part, that means that you got two variables, at least two variables, kind of holding hands together and affecting the dV differently than the individual variables. So, okay, we went over that part, but let's get back to here. So here's the moderator regression. Got all our centereds and our new variables. So we're going to scroll down to the model summary box. Wish I can get this a little bit smaller, get it all in the same frame. Oh well, I'll just move it around. So the first model, it is significant. We're looking at the F squared change over here. The first model is significant, and we knew that from coming in. We knew that the original variables, one of them was significant. It was work hours. That's why we were getting the significance here. So the second model is with the interaction term, right? So 1 is A, 2 is B, 3 is C, 4 is D, 5 is E. Don't let that part confuse you. So the second model the sugar and fat was added to the mix here. So we go to the second model to see if there was a significant change. There was not, okay? Third model is when we added work hours and fat. And it was significant, right? Right here. So work hours and fat. Work hours and fat is acting as interaction. They're interacting together in a way that they're affecting the DV in a new way. So, but we know work hours is already significant. So it might be, it looks like it's interacting with fat. Now we're going to go down here to model 4, and that's when we added the, what did we add in number 4 here? Work hours and sugar. And that too is significant. So it looks like work hours might be a moderator for both of those, for both fat calories and sugar calories. But we're only going to check one of them. I'm going to check the strong one here. And that is the one with work hours and fat calories. Okay, that's the only one I'm going to look at here. And you can't have one variable moderating more than one of the other variables. So let's keep going. We're going to look at the coefficient boxes here. Model 1, 2, 3, 4, 5. Let's simply scroll down to the last model that has all the new variables that we made here, and we'll see who's significant. So I kind of forget which one of these. Okay, so this is our significance column right here. Whoop. All right, so don't care. And sugar, fat by itself, or I'm sorry, sugar and fat, not significant. Work hours and fat, significant. Work hours and sugar, significant. So that means we do have definite moderation going in there. So now, again, I'm just going to work with work hours and fat. So now we have to decide who is moderating whom. So let me show you a quick trick on how to do that. We're going to go to correlate, partial correlation. So the DV is weight gain. And so we're going to stick in fat calories. That'll give us the correlation between weight gain and calories and fat calories. And we're gonna hold work hours constant mathematically. Okay? So if work hours is the mediator, then the correlation between these two should not be significant. And so we have some definite proof here. While controlling for work hours mathematically, the relationship between weight gain and fat calories is not significant. Let's double check. Let's control for fat calories. And if fat calories, same thing, if it is not a moderator, then the relationship between work hours and weight gain will still be significant. That's just a quick fix. We're going to go to Analyze, Partial Correlation. We're going to switch places with these guys. So fat calories, we're going to control for work hours. Again, if fat calories is not a moderator, then the relationship between weight gain and hourly work hours will be significant. And there it is right there. So it is. So in other words, it is weight gain that is acting as the moderator between the relationship between fat calories and weight gain. Ta-da! And it's probably the same thing with sugar calories as well. You probably get the exact same thing. That weight gain is acting as a moderator between sugar calories and weight gain. So it's always about how much you work. So those are the things I'm going to test you on. Practice, practice, practice. MGZ out.